As we mentioned in the last podcasts, resilience is a concept that's used very frequently and almost as a bedrock principle for adaptation, because adaptation is basically adjusting or managing the climate impacts that are already here. So it's often referred to as managing the unavoidable as opposed to mitigation, which is uh, trying to avoid the unmanageable. But if some things are already unmanageable based on your country level income or other you know barriers, then of course it doesn't matter when you think unmanageable things are going to arrive. They may already be here for some. So resilience in that sense is to make sure that adaptation also provides you longer term, you know, ways to deal with the risks that are increasing and they're uncertain. Local risk information is not available, and so on. In the context of sustaining the commons and sustainability in general, humans are part of a system of human environmental interactions, and humans influence the rest of the system by appropriation of resources, i.e., removing the system elements, pollution, i.e., adding system elements, landscape alterations, reconfiguring system elements, for example, and so on. These are characteristics of systems that help us to understand how they may evolve over long term and how they are affected by these human activities. So let's say we're deforesting the Amazon, and we assume that it's resilient and will grow back at a certain scale, at a certain time scale. But is it really so resilient, or does it have these flipping points, tipping points, threshold switches, where if you deforest it to a certain scale, then it'll just collapse? Or if the warming is combined with deforestation, will it just collapse? So the tipping point and resilience are in that sense related. Consider a young forest where the trees are small and there is sufficient light and nutrients for the trees to grow. The trees in the forest initially grow fast, and the forest starts to mature over time. The growth rates of the trees slow down when the trees get bigger, block the sunlight for each other, and compete for nutrients. Add to this the idealistic description of tree growth, the fact that forests cope with many types of disturbances such as pests, forest fires, and tornadoes, and this situation becomes more complicated. Right? So it's not just what we are doing, but with the warming and with the reduced number of frost days, pest population grows, pest infestation grows, and forest fires become more likely, and so on and so forth. If a forest experiences a fire, why does it cause more damage in some forests than others? How does management of the forest influence the size of the forest fires? We talked about Smokey the Bear and humans managing. Maybe it's in this chapter, maybe I'm confused about where I am, but human tendency to want to manage wildfires actually may have worsened many things, because in the natural system, when fuel builds up and when there is lightning or whatever other fire starter, small fires may take care of the potential for large fires, but humans are desperately managing forests for wildfires, because obviously sometimes people want to live closer and closer to the forest and sometimes in the forest, and we think wildfires are to be managed and they are universally bad and not maybe a natural regenerative system, and so on. So that's a complicated story as well. And then it depends on which kind of trees are more likely to burn or more sensitive to warming and drying, and so on and so forth, right? If forest fires are natural phenomenon, shouldn't we allow them to burn freely? These are major challenges for agencies that manage forests. Since 1944, the US has used an icon named Smokey the Bear. So I was kind of confused about whether it's in this chapter or the previous one. Smokey the Bear to, okay, let me not read the rest of the text, but this is Smokey the Bear. Only you can prevent wildfires. So this became very popular and showed up everywhere and made sense, right? So people go camping, or they throw a cigarette that they haven't stubbed out, which they are not supposed to be smoking in the first place in a national park or forest, and so on. So many wildfires are unintentionally or intentionally set by humans as opposed to natural fires. So this is obviously what was meant by the role of Smokey the Bear telling you how to behave in the wilderness, in forests in general. It expanded to other concepts as well, in trashing, etc. But you get the idea that managing forest fires is a complicated issue in terms of whether we are actually reducing the number, duration, intensity, area covered, and so on, frequency of wildfires, and so on. And other activities we do, like increasing greenhouse gases, is increasing temperatures, vapor pressure deficit, making the plants lose more water sometimes and become drier, and droughts are more, extreme droughts, flash droughts. It's a very complicated system, and if you are looking for feedbacks, that's always complicated. But this concept of resilience in ecological systems was first introduced in 1973 by the Canadian ecologist C.S. Buzz Holling in order to describe the persistence of natural systems in the face of disturbances such as fires and pest outbreaks. So we'll see that, this is Buzz Holling. A single system can have multiple types of states. For example, a lake can be either clear or green or murky. A rangeland can have a mix of healthy tall trees and with a few trees and shrubs, or it can be covered with noxious weeds, depending on whether climate change and warming are favoring such noxious weeds as well. If a system state is resilient, the system remains in that state even if it's exposed to disturbances. If a system state loses its resilience, for example due to the fire suppression, decades of nutrient loading in lakes, or overgrazing a rangeland, it may not be able to recover from even a small disturbance, which should cause it to flip into a very undesirable state. So when you say resilience and it has to bounce back to the previous state may be a new state as well, relatively speaking, considering, for example, North America has been colonized heavily in the last several centuries. What is the original ecosystem, and what resilience are we talking about, especially if you go to a state like California, where a lot of vegetation was brought in by humans in a dry region. California is climatologically dry, right? The west coast of South and North America are affected by cold ocean temperatures, and they are basically dry deserts. But population growth, agriculture, managing the ecosystems has created a different state, and now we are worried about whether that state will be resilient to climate change and human activities or not. But the concept of resilience is, of course, very critical. There are also concepts of health of an ecosystem, where you look at its complexity, its productivity overall, and its resilience to perturbation. So it depends on which metric you are looking at. So let's look at stability, or these tipping points now. So a representation of a system, the fish, that flips from one state to another state. Here is a bowl. If you remember the old story that goldfish can grow to fit the size of its pond, or its this bowl. Ek minute. So sorry, I have a cleaner coming in. Then you are going into a new state. So this is an example. On the left we have a typical Australian grassland landscape. On the right shows a pasture dominated by invasive species, the Scottish thistle in southeastern Australia, whereas this is a healthier one. This is not very grazable by the native species, where this is more of a grazing land. Okay, so let me stop this here and come back and get into tipping points. This is a bit short, but that's okay. I have to run and let the cleaners come in. Okay.